Hello. As you already know, my name is Tomasz Mucha and I am working at Nokia as a test engineer. And to be more precise, my daily job is to take care about testing environments. And to be even more precise, my daily job is hearing out people complaining about environment. And my favorite complaint I have ever heard so far is, let me give it to you, my test fails when I do not look at it. I like it very much. And the funny part, I didn't reach the funny part yet, because the tester was 100% right, and my colleague managed to find a rational explanation for such test behavior. On the other hand, what do I think? If my PC was able to read my mind, and it knows what is going on inside my head, I would like it to find a more productive application of such knowledge instead of ruining my day and failing my tests, which brings us to today's topic, because today's topic is headache interface, which is a brain-computer interface. Why headache? Because in my case, everything began with a headache. I am suffering for years for a chronic headache, and one therapy options I've been given is so-called biofeedback. And biofeedback is all about electroencephalography. You're measuring electric activity of your brain and you're trying to distinguish patterns. There are good patterns and bad patterns. For example, if you are overly stressed, it's a bad pattern and maybe it makes your head hard. What biofeedback does do with the problem? It tries to train your brain. You're playing a computer game. Here you can see an example screenshot, and if your brain behaves correctly from the electrical point of view, you gain points. The spaceship you can see here, it will probably fly straight and avoid planets and asteroids. So, when I first learned about such a therapy method, my first question was not, oh, will I be cured? Will it stop hurt? Nope. My first question was, wow, may I do it at home? Because it's incredible. In my opinion, not many things in today's world make you wow. And ability of communication between your brain directly with your PC, it's one such of a thing. So, what did I do? I bought this device. You can see here, or you can see it in my hand. It's called Emotive Epoch Plus, which is an customer-grade electroencephalography headset, which offers a C++ programming interface and also offers a simulator to speed up your coding. So during your coding, you do not have to use the real one all the time. You can just type like mad and send prefabricated electroencephalography readings from an application. And I wrote a simple game, because I always wanted to write at least one. And my game was a kind of a dungeon crawler, and it was intended to be steered by my mind alone. And what happened next? Integration testing proved it all wrong. And I would like to tell you today, why did I do everything wrong, despite of I did so many things right? But to learn more about this, we've got to take a step back to basics of BCI and electroencephalography. Of course, I'm not a doctor, but I will try to explain as much as I know and as much as it's possible in such a small time frame. Because for brain-computer interface, the root basis technology is electroencephalography, which we would call rather a major technology because it was invented in late 19th century. To be precise, in this place, in Krakow, first EEG reading was made in year 1890, quite a lot time ago. And electroencephalography is about getting insight to your brain's activity by measuring electric potential between certain points on your scalp. You are placing electrodes all over your head. And as you can see on the slide, in medical EEG, there are several patterns taken into considerations. For those of you accustomed to radio technologies, these frequencies seem to be pretty low, because the highest one is like 30 Hertz. Why do we take care about electric activity? Because everything in the brain is about electricity, because neurons communicate with each other by sending electric impulses in many different ways, but in general everything boils down to electricity alone. Of course, EEG has some limitations, and the most important one is that the electrodes are placed pretty far from the brain itself, because we've got skull, which is a pretty thick bone, and it's a good insulator. So readings are interfered a bit and rather weak. I bought a book devoted to EEG technicians, and in the very foreword to the book it was said that at first reading EEG signal may seem impossible to you, and to become a medical technician it takes years to learn. As I have stated also, EEG signal can be interpreted in many ways. Of course, BCI is a practical application of EEG. EEG is only a tool, and BCI is about getting things done with your mind. EEG is for diagnosing alone. What do we need brain-computer interface anyway, except of impressing people? First and obvious application will be removing barriers, because if you lose your limb or you suffer a stroke, you may find yourself in a situation when you are unable to communicate with the outer world, and maybe BCI would be your only chance to communicate reasonable. As I mentioned before, there's also healthcare. As I told you about biofeedback therapy, so it is believed that biofeedback that brain-computer interface can be used for treating several neurological diseases. Maybe in the future there will be an application in industry for remote controlling devices, and in my personal opinion there is a great future in gaming for brain-computer interface. As you remember, I was trying to write a game all the time. What did I get when I bought this one? I bought a 14 electrodes headset, which is more accurate than a proper medical device, and it is of course way more cheaper than a, let's say, proper one. I also got a C++ API, but only the so-called basic one, because the full professional one is additionally paid and ridiculously expensive, so I stick to the simple one, which only enabled me to get detections of predefined states. I will discuss this later on. And about the costs, it all together with shipping and taxes and customs costed me $1,000. It was worth trying, at least. What can I do with such a device? I can communicate with it in three ways. The first one is called mental commands, and though it may seem like magic, it's more like recording a macro in Excel. Because let's imagine you see a black box on your PC screen, and you're imagining, oh come on, it's moving closer to me and closer to me, and you're recording your brain activity during such imagination session, which by the way takes hours of repetitions. And once you're done, you've got your first working mental command. Of course you can record as many of them as you would like. But I stroke it out from the very beginning, because if I was to write a game and show it to anyone, I would never find a user who would be able or willing to devote hours for calibration before even playing the game. A second form of useful reading is wavebands interpretation. My device can distinguish the patterns I showed you in the very beginning, so I can deduce if, for example, user is stressed or relaxed or is concentrated on events going on the screen. But, well, it's not getting things done. It's not a way of giving orders to your PC, so no use for me. So I stick to the third possibility, which is muscle artifact. And muscle artifact is a pest for EEG technicians, because it's an interference. As we said before, the communication over neurons is about electric current. So if you are ordering your hand to move, in fact there is an electric impulse flowing to your muscles. If you're trying to smile, like me, there is also electric current traveling through nerves and make your muscles move. So, if such movement happens in a facial region, it's pretty close to the scalp. So it's an interference in EEG reading, which in BCI could be really useful. So, bottom line for me was, well, if I'm going to deal with an untrained user, I would like to stick to the third form of communication, which is muscle artifact, and we'll be smiling or showing your teeth, showing your scary face to do anything done on the screen. And I hope it sounds like fun. Sounded like this to me. The code is trivial. As you can see example of API usage. I'm just measuring if anything happens in the lower face region, if amplitude is bigger than 0, and then I'm trying to catch one of predefined events. For example, if user is smiling, then please do something. And my code seems to be okay, because, okay, there is a maze generated, and there is my character in the middle of that, and possibly by face grimaces I would be able to steer my character out of my dungeon. Which was completely false, because my very attitude was wrong. I wrote my code using a simulator, and in my imagination, in the very end, I would switch from the simulator to the real device and everything will be okay. But brain-computer interface, like this, will never replace your keyboard. How many keys do you need when you are playing a game? In my opinion, at least 4 directional arrows or WSAD if you are keen on shooters. And you are pressing these keys in a really good tempo to keep action going. And unfortunately, this guy won't do it for you, because detection rate is pretty slow and signal is not so discrete. On the keyboard, the PC always knows which key did you press. And this guy may confuse two face grimaces because, oh, was it a smile or did he or she just clenched his or her jaw to show teeth? This guy says sometime, I don't know, I'm not really sure. So, that's why I failed completely. And my sad wolf is really sad because it's unable to reach its goal. And then I had to rethink my whole approach, because, let me get you back to the previous slide, there are also possibilities, not only limitations for BCI. Because, well, let's back to the keyboard parallel. If you are trying to convince someone that you're amused, you find something funny, how many keystrokes do you need for that? Well, you may be using emoticons, so it will be like 3 or 4. Or maybe you would like to write a sentence, so there will be maybe several dozens of keystrokes. And for a brain-computer interface, all it takes is one real human smile. That's the strength of this device. So I redesigned my game completely to rely on 2 simple face grimaces, and I would like to show you a screenshot. My game is called Do Not Eat Anyone for a Minute, Please. And you can play it later on. I will go to that point. All you do in this game is making your scary face, like that, or you can raise your brow to initiate conversation. You are the red guy, and these violet guys should not be eaten. And from what I have tested so far, it works. And because it is TestDive, I would like to invite you to integration testing. And I will show my guy later on in retro gaming room. It's room number 6, I believe, when you can see if your scary face is enough to scary these guys. Well, and I believe that's everything from my side, and if you have any questions, now is the time to ask them. Thank you very much.
Okay, so that was Tomasz Mucha. Great applause for him. And let's switch to Slido for a moment. Or maybe we have some questions from our audience, like straight away. Does anyone has any question right now? Oh, great. I will just come to you.
Thanks. Have you tried machine learning? Have you tried machine learning methods in order to the code to better understand? Are you smiling? Are you grinning? Is it your scary face? How much are you going to smile?
Okay. Right now I'm relying to calibration individual for every user, but I wouldn't call it machine learning, of course. API I used offers so-called universal signatures. In the manual they said that it will work for the most of population, and so far I didn't meet anyone for whom it works. So it's not machine learning, but before you use the application, you've got to calibrate it for yourself. But of course your question is relevant. I think there is a possibility of machine learning usage.
How about face recognition techniques? Have you, which techniques or methods have you used, if you have used any, or are you planning to use any face recognition techniques?
Do you mean image processing?
Yes.
Nope. I wanted to rely on EEG alone.
Okay, thank you. Do we have any other questions from our audience?